Okay, let's move further. There's one very critical question that I often, rather invariably, I ask primary school teachers. How many are these? How do you write it? Or how do you write it? They say it's 3. Okay, and now it's 2. Now it's 1. And what if I remove it? It's 0. Very good. And what about this set? Let's say set of cherries. They said these are 1 0. What do you mean 1 0? This you said is 1, and this you said is 0. And maybe if I do set 7, this is 1 and this is 0, that might make sense. Okay, 1 has something, 0 has something, but you are telling me these cherry boxes has 1 0 something. Can you explain it? It's a very disturbing fact that not dozens, hundreds of teachers that I have encountered in training sessions, not a single teacher was able to explain it. Not able to explain it. Can we expect from such a system that eventually our child, if she is doing 23 plus 14, she is really understanding, she's simply thinking it's 3 and 4 and 7 and it is 2 and 1 is 3 and that's all. She knows the process. She doesn't know what's happening behind. Why we write 1 0, or if I add another cherry, why it is 1 1 1 1 should be something like this. They couldn't explain it. If somebody is still satisfied with the system, we can only have sympathy. Right? Then the question starts, okay, let's say there is a tribe in a Amazon forest, and they only count in 1s and 2s, right? And for example, they have symbols. This is the symbol they have made for 1, and this is the symbol they have made for 2. How will this tribe write? How will this tribe kind of write about these many cherries? Or if the cherries start coming at home, or they pick up from a tree, let's make a tree. Let's say this is a tree. Fine, this is a cherry tree. So if they pick 1 from the cherry tree, a small child goes and picks 1. How will mother write how many cherries? She will write this. Good. 1. When there was nothing, obviously she wrote nothing, let's say. What if he brings 1 more cherry? No problems. 2. And what if the child brings another cherry? What she will do when the tribe has not yet invented anything beyond it? They only count in pairs. Or they have only symbols for 1 and 2. How will she go about it? How will she write it somewhere to count how many cherries he has put? She will do something. Exactly that is what we are also doing. What she will do is, she will ask the child, can't you put them in a basket? Because there are too many, I can't write it, to put them in a basket. So she will say, okay, now I'll call it 1 basket, knowing that a basket has more than 2, just more than 2. So she will say, I now have 1 basket. And a basket has obviously 3 cherries. Means human being invented some symbols up to whatever, right? If the set of size exceeded those symbols, then they said we don't have any choice but to make packets. And when another cherry came, Oh, now I have one basket and one. Right? So, and when another cherry comes, I have one basket and two. So here I write it the simple ones, right? Simple ones, cherries. And here I started counting this many baskets, these many individuals. Precisely this is what we do and go on. We invented symbol from our hands, and our hand gave us, okay, let's have symbols for this as 1, if it is this as 2, and we went up to 9. And if there is nothing, we also invented a symbol for that. And that's also for a reason that we will automatically understand in a while. Now, if the things are more than 9, we will do the same which the old lady in the Amazon forest were doing, right? Up to this, we had no problems because we had symbols for this. Whenever another came, I have no way to write it. So I'll put all of them in a basket, right? And call them, okay, one basket. But if I simply write this one, it will confuse me. So I will put one basket. And if we add one more in our counting, it will be one basket and one, which is a simple cherry. Correct? Now we can have system of 5, or we can have system of 16. We have it in computer. We can have system of 2. We can system of any. But that's how it works. If our symbols are less than the number of objects in the set, if we get more cherries, we will packet them. And we will start counting packets. And maybe a stage comes when the number of packets also exceed then we make a larger packet. And maybe then we make even larger pallet, and then maybe we make a carton. So that's what we started. We make packets up to from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We count individuals, right? We count items. As soon as we exceed this, we start counting groups. And this should be explicitly going, things can be counted in groups also. Children, can you make a group of this? How many groups? One group. Can the girls make a separate group? Can a boys make a separate group? So how many you are? We are 2 groups. The concept of that the counting can go in groups should go explicitly, and essentially irrespective of the system of 10, we should teach system of anything. If there is a shepherd's tribe in the Sahara Desert and they count by 5, children should be able to make the way they could write. If they could write like 1, 2, 3, 4, and 5, let's say, these are their symbols. What do? They should be able to write it. After 5, up to this, they are okay. After this, they will make a basket, right? And that's essentially the place values concept. That up to our symbols, 1 to 9, we count in items and individuals, singles. After that, we make groups. And that's what we do. We are counting tablets, we count tablets. But when they exceed 9, we put them into a packet. And when the packets also exceed, let's say 9, we put them into this kind of thing, strips, and then packets, and then cartons, and then bigger carton, and then pallet, and then container, and then whatever. This sense is extremely important and extremely simple and should go as a, irrespective of what system is, our class 1 child should understand if the computer has only 0 and 1, how will it count? How will it write its counting? Thank you very much.